This is Sukriti Joshi. Our today's topic for this video lecture session is electrochemical cell. Electrochemical cell actually plays a very important role in any kind of cell reactions. It will give us an idea that how electron flow occurs from one side to another side. That means we will get an idea that whether which side behaves as anode, which side behaves as cathode. And that is also very important to know the cell potential. Okay, so here as you can see in the image, this is the image of electrochemical cell. Now, in this particular image, as you can see it, one side behaves as anode, another side behaves as cathode. Anode and cathode are interrelated or are connected with each other. So two compartments are there. One compartment is known as anodic compartment. Another compartment is known as cathodic compartment. So one compartment contains ZnSO4 solution, another compartment contains CuSO4 solution, right? So ZnSO4 solution in which we have dipped a zinc plate and Cu plate is dipped in CuSO4 solution. Okay, so zinc in contact with ZnSO4 and Cu in contact with CuSO4. Now, both of these compartments are connected with a salt bridge, which is a U-shaped tube, as you can see in the image, right? So that is known as salt bridge. And the plates are connected with a wire. Here as you can see that the SO4 minus 2 will be transferred through the salt bridge from both the sides because SO4 minus 2 is common, while ZnSO4 contains zinc and CuSO4 contains Cu plus 2. So the electron flow will occur from anodic side to cathodic side. So anode actually loses the electron while cathode accepts the electron. Okay, because cathode contains a positive charge, anode contains a negative charge. So the electron will be released by anode and it will transfer to the cathode. And cathode accepts that electron and will provide or will be there in our plate. Okay, so it's there, it behaves as a cathode, while another side, the zinc plate, will behave as a anode. Right? Now moving ahead, before moving ahead to the what do you understand by electrochemical cell, what is actually the use of it. So we have to know certain terminologies which are known as cell terminologies. That cell terminologies are very important for us. So we will take a look first of all that what are the cell terminologies and then we will move ahead. So the first one is current. What is the meaning of current? So current is the flow of electrons through a wire or any conductor. It is basically the flow of electron through any wire or any conductor. Electrode is the material which is basically a metallic rod or metallic bar or metallic strip which conducts the electrons into and out of a solution. So it behaves as a conductor for electrons. Okay. The next one is anode. Anode is the electrode at which oxidation occurs. It sends the electrons into the outer circuit. It has negative charge and is shown as negative in cell diagrams. Cathode is the electrode at which electrons are received from the outer circuit, and it has a positive charge which is shown as plus in cell diagrams. The diagram of electrochemical cell shows each and every terminology which is present in it. So electrolytes or electrolyte is the salt solution in a cell. It contains two different types of electrolytes. In one cell compartment one, and in another cell compartment it will contain another. Anode compartment is the compartment of the cell in which oxidation half reaction occurs, and it contains the anode in it. The anode is in contact with electrolyte in it basically. Okay. Cathode compartment is the compartment of the cell in which reduction half cell reaction occurs, and it contains cathode. Right? So cathode is in contact with electrolyte. Half cell. Our next terminology or next term is half cell. So each half of an electrochemical cell where oxidation occurs and the half where reduction occurs is called the half cell. Okay? Half cell is basically the half part where actually oxidation occurs, and the another one half where the reduction occurs. So you need to understand, right? Both of them are combined, or both of them are known as each half cell. Now, a device for producing an electrical current from chemical reaction, which is from redox reaction, is called an electrochemical cell. Here is the spontaneous reaction of zinc metal with an aqueous solution of copper sulfate is used. A bar of zinc metal is placed, which is known as an anode, in zinc sulfate solution in the left container. Okay, as we have seen in our earlier image also, that there are two different compartments. One compartment is known as anodic compartment, another compartment is known as cathodic compartment. So what we will do here, we have zinc in contact with ZnSO4, right? Another one, a bar of copper which behaves as cathode is immersed in copper sulfate solution in the right container. One is left container, second one is right container. So zinc is dissolved or is immersed in zinc SO4 in ZnSO4 solution, and copper rod or copper bar is immersed in CuSO4 solution. Okay. So the electrodes are joined by copper wire, a salt bridge containing potassium sulfate solution. Okay, and interconnects the solutions in the anode compartment and in the cathode compartment. So the oxidation half reaction occurs in the anode compartment is as follows. Zinc gives zinc plus 2 electrons. So 2 electrons are actually released, right? So that 2 electrons released from that particular part which is known as anode, and it will travel towards cathode, which is connected with a copper wire. The reduction half reaction which takes place in the cathode compartment is Cu plus 2 electrons gives Cu. So Cu bar accepts 2 electrons and will convert itself into Cu, right? So that part will behave as cathode. One is anode, second one is cathode. Right? Now, when the cell is set up, the electron flows from zinc electrode through the wire to the copper cathode. Okay. As a result, the zinc dissolves in the anode solution to form the zinc plus 2 ions. The Cu plus 2 ions in the cathode half cell pick up the electrons and are converted to Cu atoms on the cathode. At the same time, SO4 minus 2 ions from the cathode half cell migrate to the anode half cell through the salt bridge. Right? Now let's take a look on what is a salt bridge actually. So the salt bridge is a U-tube filled with an electrolyte such as NaCl, KCl or K2SO4. It provides a passage to the ions from one compartment to the other compartment without extensive mixing of the two solutions. With this ion flow, the circuit is complete and the electron pass freely through the wire to keep the net charge zero in the two compartments. This flow of ions from one half cell to other completes the electrical circuit, which ensures continuous supply of current. The cell will operate till either the zinc metal or copper ion is completely used up. And the zinc copper cell can now be written as or can be represented as zinc plus 2, which is known as anode half cell with salt bridge Cu plus 2 in contact with Cu, which is cathode half cell. So it shows us the actual representation that how zinc solution is in contact with zinc plus 2, is in contact with salt bridge, the salt bridge is in contact with Cu plus 2 and which will convert it to Cu. Right, so it shows that anodic side gives an electron, cathodic side accepts the electrons. The EMF of the cell can be calculated from the half cell potentials of the two cells, which is anode and cathode, by using the following formula, which is known as E cell is equal to E cathode minus E anode, which is ER minus EL. So always we have to first take cathodic cell potential and then we have to go for anodic cell potential. Right? Let's move ahead to the numericals. So determination of EMF of the standard zinc half cell using a calomel electrode. So the zinc half cell is connected with the standard calomel electrode as shown in the figure. The EMF of the complete cell is then measured with the help of voltmeter and it is found to be 1.040 volts. Since zinc forms the negative electrode of the cell, its EMF with respect to calomel electrode will be minus 1.040 volts. The addition of 0.280 gives the standard electrode potential of the zinc. So here minus 1.040 plus 0.280 is equal to minus 0.76 volts. So this particular table shows standard reduction potentials at 25 degrees Celsius or at 298 kelvins. Right? So for different reactions, I have shown you here different ones. For hydrogen one, that is 2H plus 2 electrons gives H2. So you will get here 0 potential for that. Okay. Now let's take a look on numerical. So we have to calculate the EMF of the given cell here, which is zinc in contact with zinc plus 2. The concentration of it is 0.001 molar. With salt bridge in contact with Ag plus, which is 0.1 molar in contact with Ag. So the standard potential of Ag oblique Ag plus half cell is plus 0.80 volts, and for zinc oblique zinc plus 2 is minus 0.76 volts. The half cell reaction for anode and cathode are given below. When anode and cathode half reactions are added, the total cell reaction and the value of E0 can be as follows. So on cathode, 2Ag plus takes 2 electrons and converts itself into 2Ag. At that time, the value of E0 is plus 0.80 volts. On anode, zinc releases 2 electrons and converts itself into zinc plus 2. And 2 electrons are released from them. So that will become anode. So E0 is equal to minus 0.76 volts. Now the total cell reaction and cell potential is as follows. Zinc plus 2 Ag plus gives zinc plus 2 plus 2 Ag. This is a both side reaction. Okay, reversible reaction. Now E0 here is equal to 1.56 volts. Substitute the given values in the Nernst equation and solving for E0 we have here E cell is equal to E0 cell minus 0.0591 divided by N into log K. So the value of E0 cell is 1.56 minus 0.0591 divided by 2 into log zinc plus concentration of zinc plus 2 by concentration of Ag plus raised to 2. So if we put all the values there, 1.56 minus 0.0591 divided by 2 into log, that is concentration, that is 10 raised to minus 3 divided by 10 raised to minus 1 raised to 2. So we will get a term which is equal to 1.56 minus 0.02955 into log raised to 10 raised to minus 1. So we get the term which is 1.56 plus 0.02955. And at the last we get E cell is equal to 1.58955 watts. So that will give you the EMF of the given cell. So we can write that the EMF of given cell is 1.58 to 955 watts. Okay, this is all for this session. Thank you so much.